Hey guys, sorry I couldn't be there today. You've done this before, you know how this works. You're going to watch this video, follow along with me. You have, at this point, ideally uploaded the square roots guided notes that you can find in the modules of the Canvas app. This is a brand new unit, and we're going to start talking about trigonometry. In fact, the third assessment period is going to be very geometry heavily based. So let's begin. We got to start talking about square roots before we start talking about trigonometry because it's an important part of something called the Pythagorean theorem, which maybe you've heard of before. If not, no worries. We're going to be talking about it in great detail this unit, and it has to do with square roots as well. Okay, so let's begin. As you know, there are four main mathematical operators. Remember, an operator is anything that causes a change in a number, just like a normal operation causes a change in the human body. Well, a mathematical operator causes a change to a group of numbers. So there's addition, subtraction, multiplication, and division. This you've known for many, many years. But are these the only operators? Of course not. There are so many. We know this one. That squares a number. That multiplies it by itself. We're going to talk about that one today. This is the square root operator. That takes the number back to its squared root. We'll talk about that one today. This one we know. That's another operator. That's factorial. That's right. And then this one's kind of new. You haven't seen this one before. You will be seeing it the older you get. It's called the summation. It's very similar to factorial, except instead of multiplying the numbers together, you are adding them. So if I were to say, what is the factorial of, say, I don't know, 4, that would be 4 plus 3 plus 2 plus 1. And then you would actually find out what that sum is, which is why it's called a summation. And this is the capital letter, Greek letter, sigma. Yeah. So if I were to ask you what's the summation of, 10, it would be 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. And you would actually find out what that sum is. So that's another one that's quite common that is used a lot in statistics. All right, but let's talk about something squared, all right? Square, as we know, means to the second power. So if we had this chart right here and we wanted to fill this in, let's do it. 0 squared is 0 times 0, which is 0. 1 squared is 1 times 1, 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. I just gave you that answer. You know what? You continue filling in the rest. Go for it. I'll pause it now, and you pause it too, and fill in the rest. Did you fill in those numbers? 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. All of these numbers that we have just written in blue, these are called perfect squares. So all these numbers that we just wrote are called perfect squares. Not every number is a perfect square. While there are an infinite number of perfect squares, because we can keep doing this, 16 squared, 17 squared, 18 squared, 19 squared, forever, these are the perfect squares. We got to make sure that we have these in our mind because they come up so often in mathematics. So make sure you have that filled in. Let's keep going. A perfect square is any number that is the square of an integer. Here's the definition. A square of an integer. In other words, you square an integer and you get a perfect square. All those numbers that we just saw, the 1 squared, 2 squared, 3 squared, 4, the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all of those, as we know, are integers. Remember, integers are positive numbers, negative numbers. Yes, you can square a negative number. Or 0. Those are integers. Well, why are they called perfect squares? Well, here are just a few of the perfect squares. You got 16, 25, 36, 49. They're called perfect squares because, look, if we were to actually list out 16 little dots, we can organize them into, that's right, a perfect square. You see? You can go ahead and count them up, but right here we have 4 by 4. 4 rows, 4 columns. And that, of course, as we know, makes a square. That's why it's called a perfect square. And that can only happen with numbers like 16, 25, 36, 49. Here, I'll do it for 25. Go ahead and count them up. There's 25 little blue dots right here. Some of them got into the wording down here, but you can see that all 25 of them there. I have 5 rows, 5 columns, and there are 25 in there. So thus making a square, 5 by 5. Go ahead and make your perfect square for 36 and 49 right here and here. And you know how many rows and columns you need for 36. You'll need 6 rows, 6 columns. And for 49, I'll let you decide that. Go ahead and make your little dots. Go ahead now. Alright, nice job. I'll check that later on yours. Now let's talk about what is meant by the word root. Because we got to start talking about the square root. Well, when you think of the word root, what do you think of? Yeah, I think of a plant as well. Or maybe your family's roots. Well, a plant's roots, or your family's roots, are the beginning of a plant, or the beginning of where a family came from, whether it be a country, or whether it be a location, or whether it be a select people. The root of anything means, that's right, a beginning. Yeah. The root of anything means a beginning. Now, why is it called a square root then? Because it has the word root, and we know the word root means beginning. Well, basically, it's where a square begins. That's what we're talking about when we talk about a square root. It's where a square begins, the root of it, because it's a square root. We're going back to that square's beginning, aka we're going back to that square's root. So the fact that we know the perfect squares means we can go in the reverse direction and find out the square's beginning, aka the square root, which we'll be doing in just a moment. But there's some information about a square root that maybe you don't know just yet that we're going to talk about in just a moment. Now, one thing we also know is that there are things called inverse operators in mathematics. There's addition and subtraction. Those are inverse operators. We've used those before. Multiplication and division, meaning if you want to undo multiplication, use division, and vice versa. If you want to undo addition, use subtraction, and vice versa. But every single operation, not just the 4 main ones, but every single operation in mathematics has an undo button, a way to reverse that process. So what's the opposite of squaring a number? It's going back to its beginning, aka its square root. And we're going to need to use this pretty often in mathematics, okay? This is a very, very helpful tool. We know that addition and subtraction undo each other, multiplication and division undo each other. Well, to undo a square, you take the square root, and vice versa. To undo a square root, you square it, which is something we're going to be doing in just a moment. The opposite of squaring a number is taking the square root. Its square root. All right, now keep that in mind because we're going to be using that pretty often. So let's actually use that. We know 25 squared, kind of a larger number, is 625. You can go ahead and confirm that if you wish. 25 times 25 is in fact 625. But what if I asked you to take 625 and take its square root? In other words, go back to the beginning. Well, what would that be? Where does the root of 625 come from? In other words, what is the root of 625? In other words, what is the square root of 625? Well, we know to find the square root, we ask ourselves the following information. What 2 numbers? What exact same 2 numbers? That's right, that's the key. What are the exact same numbers that multiply together to give us 625? So what times what gives us 625? Now there's a lot of numbers that multiply together to get 625. Those are called factors, but we need 2 specific factors that happen to be the exact same number. So I guess you can think of it as one specific factor that multiply together to give 625. Well, we know that must be 25, because 25 times 25 gives us 625, as we just saw. But if we go back to 625's beginning, aka its root, we see that it starts at 25. That's how we got 625. So we're just going then through this loop here. All right? This is why we call it a square root, because it takes the square and finds its beginning, its root. So here we have a lovely table right here that we can now fill in. We know a lot of these square roots. We've used them before. The square root of 0 is 0. The square root of 1 is 1, because 1 times 1 gives me 1. What 2 numbers multiply together? Same 2 numbers to get 4. That's right, it's 2. And 9? 3. What 2 numbers multiply together to give me 16? What same 2 numbers? 4. Square root of 25, that's a very, very common one. We know that's 5. You go ahead and fill in the rest here right now. Pause the video and please do so. Nice job. Surely you noticed this very simple pattern. We were just counting to 15. And based on the previous chart that we filled in, the perfect squares, we undo those perfect squares by taking each perfect square's root. So the square roots are right here. Now, are these all the square roots? No, of course, there's an infinite number of square roots. However, these are the main ones that we need to know, that we need to make a chart and have memorized. So if anyone would like to make a poster, go right ahead. However, what I'm about to say may surprise you. This chart right here is not complete. It's almost complete. We have the right numbers, but we're missing particular symbols. What do I mean by that? Well, let's think about something. We know the square root of 100 is 10. And we know this because 10 times 10 is equal to 100. But is the square root of 100 only the number 10? I'm telling you right here, right now, that that's half the truth. We know half the answer. Where's the other half to this answer? Well, let's think about something we've already known for quite some time. We know that all square roots have, in fact, 2 answers. Well, maybe we haven't known that for a while. This is new information for us. Keep this in mind. All square roots have, in fact, 2 answers. Well, what are the 2 answers? We know that positive 10 times positive 10 gets me 100. But what we have known for a while is that negative 10 times negative 10 gets me what? Negative 100? No. A negative times a negative is a positive. So negative 10 times negative 10 is 100. And we also know that the square root of any number asks us to figure out what 2 of the exact same numbers multiply together to get me the number underneath the square root sign. Well, we know the square root of 100 is 10 because positive 10 and positive 10 give me 100. But now that we also remember that negative 10 times negative 10 gives me 100, the square root of 100 is not just positive 10, it is also negative 10 by definition of what a square root is, because a square root asks you to find the exact same 2 numbers that multiply together to get you the number underneath the square root sign. Well, what 2 of the exact same numbers multiply together to get 100? Positive 10, and we remind ourselves that negative 10 also does, because negative 10 times negative 10, which is the exact same number, multiply to get positive 100, and that's what's underneath the square root sign. So instead of writing positive 10, we have to say this. This symbol might be new to you. It's called plus or minus sign, and if you look at it carefully, all right, it's a plus sign stacked on top of a minus sign. So what we're saying here is plus or minus 10. So the square root of 100 is not 10. It's plus or minus 10, thus giving us both answers, thus giving us the full answer. And this is something we have to remind ourselves from right now. When you say plus or minus 10, you're saying the number 10 and negative 10 without having to write it twice as I have. You're saying the positive version of 10 and the negative version of 10 in one compact symbol, plus or minus. Let's use that often. Plus or minus 3 means positive 3 and negative 3. Say it out loud. Plus or minus 19.2 means positive 19.2 and negative 19.2. Say this one aloud. Plus or minus 3/4 is plus 3/4 and negative 3/4. Plus or minus 88 is positive 88, negative 88. So what we have to do is we have to go back to this square root chart now, and we have to fill in the plus or minuses, because we're not completely done with that. Thus, ladies and gentlemen, this square root chart, as I said, is not fully complete unless we be specific. The square root of 0 is not just 0, it's plus or minus 0. Although you wouldn't really have to write plus or minus 0 for 0, but for 1 you would. The square root of 1 is plus or minus 1, because it doesn't negative 1 times negative 1 also give you positive 1? And the square root of 2, square root of 4 isn't 2. It's plus or minus 2, because doesn't negative 2 times negative 2 give you 4? Square root of 9 is not just 3, it's plus or minus 3. Negative 3 times negative 3 also gives me 9. Square root of 16, negative 4 times negative 4 gives me positive 16. Square root of 25? Yeah, it's plus or minus 5 because negative 5 times negative 5 also gives me 25. Go ahead and fill in the other pluses or minuses now. Now our chart is complete. Every single square root has a positive version and a negative version of itself because a negative times a negative also gives me a positive, and it always will, something we've known for a while. So, for years we've probably been thinking that the square root of a number is always a positive number. See, it doesn't have to be. The square root of any number is going to be a positive version of the number and a negative version of the number. Remember, those are called opposites. The opposite of 9 is negative 9. The opposite of 14 is negative 14. The opposite of negative 13 is positive 13, and so on. So nice, now we have our completed chart. So this is what we need to see. A lovely poster of this, including the pluses or minuses. Always welcome, always welcome. All right, we also need to consider non-perfect squares. You know, we know 25 and 16, 36, 49, 64, 81. All those are perfect squares, but what about non-perfect squares? What if I asked you what the square root of 5 is, or 102, or 1,585, or 27.8? Well, for those, for now, we're going to be using a calculator, okay, to help us solve these. And when we do, I want us to round to the nearest tenth. That's the first decimal place, as we know. And we'll use a calculator for that for now. As we go into more higher levels in the months and the weeks to come, we'll learn how to actually give a simplified version of these. But for now, let's just find out what a calculator is. We know, what are the exact same two numbers that multiply together to get 5? Well, we know it's got to be between 1 and 4. But what is it specifically? Well, go ahead and use a calculator. You'll see. And if you round to the nearest tenth, you'll see, oh, it's 2.2. But if you write this answer, ladies and gentlemen, again, you're only going to get half credit because you've given me half the answer. What else do I need? Plus or minus 2.2. That's right, plus or minus 2.2 will give me 5. Because positive 2.2 and negative 2.2 multiplied together will give me positive 5. What about the square root of 102? Well, we know that's not a perfect square, that's not on our list, but we know it's going to be around 10 because it's pretty close to 100. But because 102 is greater than 100, we know it's going to be a little bit over. Go ahead and use your calculator. You'll find that it is 10.1. But again, you give me this answer, you're only giving me half the truth. Plus or minus 10.1. Remember, you got to put that plus or minus in from now on. Go ahead and try the other two. Square root of 1585, the square root of 27.8. Pause the video now and calculate that. Round to the nearest tenth accurately. Did you get plus or minus 39.8 and plus or minus 5.3 for these last two here? If you did, nice job. You rounded accurately, so nice job. Nice job. All right, let's keep going. All right, so let's use this knowledge of square roots to help us evaluate. Now remember, evaluate is something we've been doing since the beginning of the year. And evaluate the expression when x is 72 and y is equal to 8 means nothing more than basic plug and chug as we've known it for so many weeks. We're going to remove every instance of x, and we're going to replace it with 72. We're going to remove every instance of y that we see and replace it with 8. So let's start with the first one, the square root of x minus y. All right, well, the square root of x minus y, that's the square root of x, which is not going to be x anymore. We're going to replace that with 72 minus y. Well, y we know to be 8, so we're going to replace that with 8. Now, one thing to understand is that the square root sign is sort of like parentheses. You don't treat them as parentheses, they are in fact an operator. But as we've known for a while, that when you're doing order of operations, grouping symbols come first, and grouping symbols do include parentheses, but another example of grouping symbols is that of the square root sign. So we have to first do 72 minus 8 before we take the square root of anything. So let's actually do this math here, 72 minus 8. Okay, so let's see, 72 minus 8, go ahead and confirm that with me, but that is 64. So what we're really looking at here, once we simplify it, is the square root of 64, which we'll write 8. And if you write 8, guess what? You get half credit. Why? Because it's not just 8. Yeah, it's plus or minus 8. Positive 8 times positive 8 gives me 64. Negative 8 times negative 8 also gives me 64. So don't neglect the plus or minus. Alright, I'm going to help you to plug in the x and the y in the next one, and then you'll take over from there. Notice that we have a plus 1. That's just a normal plus 1. We don't change that out with any number because it already is a number. So this is the square root of x, which is 72, plus y, which is 8, plus 1. Alright, you continue from here. Pause the video now, and please try to finish this one, and then try negative 4 square root of x times y. Did you get the square root of 81, thus leading you to plus or minus 9? Because if you did, pat yourself on the back. Nice job. Alright, now this last one. Careful. This negative 4, right outside the square root sign, it means, what do you think? Addition, subtraction, multiplication, or division? If you said multiplication, you were right. It's negative 4 multiplied by the square root of x times y. We know xy is x times y. So therefore, what we need to do is first multiply the x and the y. Then we need to take the square root of that. Then we need to multiply that by negative 4. But there's a kind of a weird way to do it. Here, I'll start you off. This is negative 4 multiplied by 72 times 8. Notice that I put parentheses around the 72 and the 8. Well, what is 72 times 8? It's 576. And we're multiplying it by negative 4. Alright, so now what do we need to do? Well, what is the square root of 576? Careful again, it's not 24, it's plus or minus 24. But what we still have here is the negative 4 out in front. So we have to ask ourselves, how do we multiply a negative 4 times a plus or minus 24? I want you to try it. Pause the video now, see what you come up with, and then I'll show you the answer in a moment. Did you think of it like this? We're saying negative 4 times plus or minus 24, so we could split it up as either saying negative 4 times positive 24, or negative 4 times negative 24. Alright, well, what's negative 4 times positive 24? Negative 96. And what's negative 4 times negative 24? Well, that's positive 96, because once we, again, a negative times a negative is a positive. So our two answers are negative 96 and positive 96. Oh, but look at that. Once again, we see that a positive and a negative version of itself are being used. So your final answer is nothing more than plus or minus 96. So once we have our plus or minus in place, we are ready to go. Nice job. Nice job. Okay, we got to talk more about this. And let's reverse this process by solving for the variable. Now remember what we said at the beginning of the lesson. We said that everything has an undo button. In other words, everything has an inverse operator. The undo of addition is subtraction. The undo of subtraction is addition. The undo of multiplication is division. The undo of division is subtraction. Or division is multiplication, excuse me. Woo. What's the undo of squaring something, as we see here? Well, how do we solve for the variable? Remember, to undo a square number, you use the square root. So if I asked you to solve for x, remember, we want to isolate x. We got to get rid of this little 2 right here. But how do we do it? We don't subtract it, we don't divide it, because this is not x times 2, and this is not x minus 2. It's not x plus 2, it's not x divided by 2, it's not x times 2. No, no, no. It's x to the second power. Well, what is the undo of something squared? Well, to undo a square number, we use the square root. So to solve, what is x squared is equal to 64, this little 1, we have to take the square root of x squared. Because the square root of x squared is nothing more than x. Because these two operations cancel each other out. The little square and the square root button go away, and all you're left with is x. And that's equal to, well, one thing that we've known for many weeks now, is that if you do something to one side of the equation, you have to do it to the other side. Since I took the square root of x squared, I also have to take the square root of 64, which is what? Not 8, plus or minus 8. That's right, it's plus or minus 8. So now we have our answer, x is equal to plus or minus 8. I'm going to show you that you can even check your work here with both solutions, and it does work. How do you do that? Well, we go back to the original untouched equation, and we're going to swap out this x for both of our answers, a positive 8 and a negative 8. So we do have to check this twice. So if I replace this x with a positive 8 and everything else remains the same, do I get an accurate statement? 8 squared is, 64 is equal to 64. So it did work here, but that's not enough. We have to check our work twice, because not only is the answer positive 8, it's also negative 8. So once again, go back to the original untouched equation, and let's swap out this x this time for the negative version of 8. So negative 8 squared will equal 64. Is this going to give us a true statement? Here is hoping. Well, what is negative 8 squared? It's negative 8 times negative 8, which is, 64. So yes, we also get a correct version of itself when we swap out for negative 8, right here, as we did. So the positive version of 8 and the negative version of 8 also work. Keep this in mind. How would we solve this next one? Well, let's see here. We want to figure out not just what y squared is, but what is y. So we got to get rid of this little 2, which we know is a square. We're squaring the number y, or the variable y, whatever it is. All right, so what we need to do is take the square root of that, because as we know, the squared root and the square cancel each other out, and we're just left with y. But if you take the square root of one side, you got to take the square root of the other side. So what do you get? You get y is equal to square root of 324. What times what gives me 324? Well, 324 is in fact a perfect square, and the answer is 18 times 18 gives me 324. But if you just say that, you're only giving me half the truth. Plus or minus 18, because negative 18 times negative 18 is in fact 24. Go ahead and check your work for that one now. Alright, ideally you just checked your work for this one and you saw that you'll get 324 is equal to 324 on both accounts. What happens if we needed to solve this? Notice that the variable's on the other side of the equal sign. It was on the left here, now it's on the right. Big deal, nothing has changed. Take the square root of n squared. But if you take the square root of n squared, you have to take the square root of the other side as well. And we know the square root of 225 from our chart is 15. So 15 is equal to just n, because the square root and this square cancel each other out. But why is this only half the answer? That's right, plus or minus 15. Plus or minus 15. And it works. Go ahead and check your work for this one as well before we go on to more challenging problems. Alright, we're coming to the end. We're going to put together everything that we have just learned. We have 1, 2, 3, 4 problems to do, okay? And anything that we don't get to, anything that we don't finish, or anything that I assign to you must be drop-boxed, and I will look at it in the afternoon. Here we go. 5y squared is equal to 48. Uh-oh. We haven't seen this coefficient in front of the variable squared yet. We got to learn how to solve that, okay? Well, we just want y alone. And if this were just 5y, if this 2 were not there, if it were just 5y, like ignore this for the time being, this squared. If that were just 5y, we know exactly what we would do. We would divide both sides by 5. Well, guess what? Just because that squared is there changes nothing. I'm going to tell you guys something. Listen carefully. Always square root your variable last. That's right. Start by dividing 5 to both sides. And yes, you'll get a decimal. Big deal. We know how to handle decimals. We're going to get here. These 5's cancel each other out. This we've known for a while. And we're left with y squared is equal to 48 divided by 5. Round to the nearest tenth once again, and you get 9.6. But we're not done. We still need to get rid of this squared here, because what we want always is just the variable, not the variable squared. So what do? Just like before, take the square root of both sides, because y squared, the square root of y squared cancels out and becomes y. And the square root of 9.6 we'll need our calculator for, It's 3.1, but it's not just 3.1, it's plus or minus 3.1. And there we have our answer. So notice that we divided both sides by 5 like we've been doing for oh so long. Oh so long. You know what? Try this one on your own now. This 2x squared is equal to 32. Let's see how you can handle that one. Pause the video now and please try it. Alright, let's see what you got. I start out by dividing both sides by 2 because I want to isolate my x. It means I need to get rid of the coefficient 2 and the square of 2. Oh, excuse me, the square of x, which means these 2's cancel out, so I'm left with x squared is equal to 32 divided by 2, which we know is 16. Then I finish this off by taking the square root of both sides because I know those will cancel out, and I'm just left with x is equal to the square root of 16, which is not just 4, it's plus or minus 4. So my answer is x is equal to plus or minus 4. Done. Alright, I'm going to do one more with you, and then it's up to you to do this one on your own. Okay, this 90 is equal to 1.5x squared plus 8. I want to see how you can do that one. Some decimals, yes. Feel free to use a calculator. And remember, your final answer is going to be plus or minus some single number. And it will be a decimal for this one. Heck, it's going to be a decimal for this one. Look, this is 5y squared minus 4. I'm going to do this one with you. Do I get rid of the 5 first or the minus 4 first? Well, again, imagine if this little squared was not there. And if we're just 5y minus 4, you would know exactly what to do. That's right, you add 4 to both sides. You add 4. See, the first thing you get rid of is the minus 4 because you're reversing the order of operations as we've done in the past. So what we're having here is 5y. We know negative 4 plus 4 is 0. And 74 plus 4 is, of course, going to be, yeah, that's right, 78. Now, just because this squared is now back there changes nothing. This squared is still there. So we have 5y squared is equal to 78. Well, now we're kind of back to what we just saw. Always get rid of the addition or subtraction first because it's the reverse of the order of operations. That's what algebra is. So therefore we have to go backwards through the order of operations, which means we use addition and subtraction first. And in this case what we did was we added 4 first. So let's continue. We divide both sides by 5. Remember, you take the square root last, so we get rid of those 5's, and we're left with y squared is equal to 78 divided by 5, 15.6, and I'm rounding to the nearest tenth as I'm going to do throughout this whole these notes here. Now I have y squared is equal to 15.6. I am close to being done. How do I get rid of this little squared right here? I take the square root of both sides. So therefore this square root and that square cancel out, and I'm left with y is equal to the square root of 15.6, which you might put as 3.9, and if you did, good job. However, I can only give you partial credit because it's plus or minus 3.9, so keep that plus or minus in check. Alright, here is what I want you to do now. I want you, on your own, to solve 90 is equal to 1.5x squared plus 8. Try that one on your own. Fill it in right here. I will be checking your response. We will start class by going over this one along with your probability and odds test, which will be returned to you next class. Your results can be seen on Canvas, of course. Many of you, I'm sure, have seen it. And we'll go over the test, and we'll go over this one next class. Feel free to stop right here, okay? These word problems here, we will tackle those, and everything past this point, all the next word problems, we'll tackle those in future classes. Right now, I just want you to get the mathematics of solving for a single variable with roots, square roots, and squares. Alright, have a good day, folks. Good luck on Terra Novas as well. I will see you next class.